Hello everyone, welcome to the SQRT channel. In this video, we are going to take a problem from Bulgaria Math Olympiad from 2018. In this problem, we have two fractions. In the first one, we have 6 over 5 to the power of SQRT root of 3, and for the second one, we have 5 over 4 to the power of SQRT root of 2. We are going to decide which one is bigger. Before moving forward to talk about the solution, make sure that you pause the video to think about this very interesting problem. Before moving forward to talk about the solution, I'm going to add more details here. So in the original problem, we wanted to prove that the left hand side is bigger than the right hand side. This is indeed very interesting and challenging problem. I first posted this problem in our Twitter account. We got a lot of interest, but none of the answers were correct. Then I posted the question again, and this time we got some new answers. They were wrong and right, but too complicated. So let's see how we can solve this problem with a rather simple approach. Now let's try to solve this problem. So we have two fractions. The first one is 6 over 5 to the power of SQRT root of 3, and the second one is 5 over 4 to the power of SQRT root of 2. So I'm going to do some trick here. So first of all, I'm going to take power of SQRT root of 3 for both fractions. For the first one, we will end up with 6 over 5 to the power of 3. On the other hand, for the second one, we will reach to 5 over 4 to the power of SQRT root of 6. You might say, what's the point here? SQRT root of 6 is still a bad number. So let's see what we can do with this SQRT root of 6. Note that you cannot just take power of 2 of both sides and say that we are going to remove SQRT root of 3 and SQRT root of 2 and just ended up with 3 and 2. And the reason is simple. If you take the power of 2 of this, you are not going to end up with 6 over 5 to the power of 3. Instead, you are going to end up with 6 over 5 to the power of 2 times SQRT root of 3. The same thing happens for the other fraction. Now we need to prove that 6 over 5 to the power of 3 is greater than 5 over 4 to the power of SQRT root of 6. Remember, SQRT root of 6 is less than SQRT root of 9, so we can write it as 2 plus x, and we are going to find out what x can be. Instead of doing that, I'm going to take power of 2 of both sides. On the left hand side we will have 6, and on the right hand side we will have 2 plus x to the power of 2. If we simplify it at the end, we will end up with 2 is equal to x times x plus 4. Now instead of finding x, I'm going to write it as a fraction. I'm going to write it as xn is equal to 2 over xn minus 1 plus 4. And we are going to start with x0 is equal to 1 over 2. Let's take a look at the fraction that we found. We wrote xn is equal to 2 over xn minus 1 plus 4, and we started with x0 is equal to 1 over 2. So if we put x0 and find x1, we are going to end up with 4 over 9. If we use 4 over 9 and then find x2, we will end up with 18 over 40. And if we repeat this, we are going to end up with 80 over 178 for x2. Remember, we wrote SQRT root of 6 as 2 plus something, and we are going to find the value of that fraction that if we add 2 to it, we are going to end up with SQRT root of 6. You can imagine that as we increase the indices and as we go from x2 to x3 to x4 to x5 and so on and so forth, we are going to move towards the exact value that we have for SQRT root of 6 minus 2. Let's take another look. We started with x1 is equal to 4 over 9, and we know that 2 plus x1 is going to be SQRT root of 6. 2 plus x1 is actually 22 over 9. And now we want to see if 22 over 9 is greater than or less than SQRT root of 6. I'm going to write 22 over 9 as radical 22 over 9 to the power of 2. And we know that 9 to the power of 2 is 81 and 22 to the power of 2 is 484. 484 is a little less than 486. And we can see that 22 over 9 is actually less than the square root of 6. On the other hand, if you take x2 as the initial point and use 2 plus x2 to find a square root of 6, you will end up with 49 over 20. And if we repeat the steps that we took, you can see that 49 over 20 is actually greater than a square root of 6. So what do we know now? First of all, we want to prove that 6 over 5 to the power of 3 is greater than 5 over 4 to the power of a square root of 6. We showed that a square root of 6 is between two fractions. On the left hand side we have 22 over 9, and on the right hand side we have 49 over 20. So instead of using a square root of 6, we are going to use 49 over 20, since 49 over 20 is greater than a square root of 6. So let's start with that. What we are going to do is to show that 6 over 5 to the power of 3 is greater than 5 over 4 to the power of 49 over 20. I don't like the fraction that we have for 49 over 20. So let's take the power of 20 from both sides, and then we will have 6 over 5 to the power of 60 compared to 5 over 4 to the power of 49. And now we are going to show that this is the case and the left hand side is greater than the right hand side. I'm going to do a trick here. So we have 5 and 4 in the fraction. I mean in the denominator of the fraction. So I'm going to make them exactly the same. To do this, I'm going to multiply both numerator and denominator of the left hand side by 4. We will end up with 24 over 20 to the power of 60. On the other hand, for the right hand side, I'm going to multiply both numerator and denominator by 5. So I will end up with 5 times 5 or 25 over 4 times 5 or 20. So now I need to show that 24 over 20 to the power of 60 is greater than 25 over 20 to the power of 49. Since we have 20 in both denominators, I'm going to remove that. And what I'm going to show that is 24 to the power of 60 is greater than 25 to the power of 49. Now I'm going to write 25 as 24 plus 1, and we will take it from there. Let's expand 24 plus 1 to the power of 49 for now. We're going to write it as 49 choose 0 times 24 to the power of 49 plus 49 choose 1 times 24 to the power of 48 plus, and so on and so forth. Now I'm going to divide this by 24 to the power of 49. The reason is simple. Remember, we had 24 to the power of 60 and 25 to the power of 49, and we wanted to compare them. Right now we constructed 25 to the power of 49, and I just want to remove the common term that they have, so I divide both sides by 24 to the power of 49. Let's do that. We are going to end up with 1 for the first term. 49 choose 1 over 24 for the second term. 49 choose 2 over 24 to the power of 2 for the third term, and so on and so forth. Let's take another look. In general, we have 49 choose k over 24 to the power of k, and we want to see how large this can be. Let's start with k is equal to 1. We have 49 over 24, which is a little more than 2. For the second one, when we put k is equal to 2, we will end up with 49 choose 2 over 24 to the power of 2, which is 49 times 48 over 2 times 24 times 24. This is 1.33 approximately. If we use k is equal to 3, we will end up with 0.63, and if we continue this, you will see that the value that we get out of this term is going to go smaller. So in general, the values that we have are not big. Now you can see that in general we have approximately 50 terms, and almost all of them are less than 1, and a few of them, let's say that the first term is 1, the second term is 2 point something, the third one is 1.33, and so on and so forth. So they are not big, and if you add them together, they are by far less than 24 to the power of 11, and that proves the problem that we had. Thanks for watching the video. If you would like to see more puzzles, math involved activities, and problems from different competitions and math olympiads, please kindly subscribe to this channel. See you in the next video.